All right, guys, so we finished chapter 1 and we're starting chapter 2 today. Now, luckily, unlike chapter 1, which was a little bit all over the place with section to section, chapter 2 and chapter 3 are going to focus very much on a single topic and not jump around like the others did. So with this here, the main focus of this section, this chapter, is going to be quadratic functions. We're mainly going to be focused on quadratic functions for this here. And we consider a function to be quadratic with our f of x equals x squared. This is the parent function of a quadratic. And the reason we call it a quadratic is the x squared, that second power. Because we can have also y is equal to x squared plus 2x plus 1. This is also considered a quadratic because of that x squared term. Now, what we're looking at it today are transformations. We've done transformations before. This is moving it up, down, left, right, stretch, shrink, and our reflections. Now, whenever we have a number or a term in the a spot, this a is doing two things. One of them is a reflection across the x-axis. Because if there is a negative where a is at, it's a reflection across the x-axis. Now, if there's a number there, it's going to be either a vertical stretch or shrink. It's a vertical stretch or shrink. Because if the number is between 0 and 1, it's a shrink. If the number is greater than 1, it is a stretch. The next piece we have is the h. Inside the parentheses is our horizontal translations. And this is our left or right. And again, inside the parentheses, we said is the opposite of what we think. If it looks like it's moving to the left, it's actually moving to the right. Or if it looks like it's moving to the right, it's moving to the left. And we'll see more of those here in a second. And the last part is our plus k. And this k is our vertical translations. This is our up or down, moving the graph or the function up or down. And that's exactly what we think it is. So if we have plus 4, it's going to move it up 4. If we have minus 4, it's going to move it down 4. Outside the parentheses is exactly what we think it is. Inside the parentheses is the opposite of what we think it is. And we've done some of these here before in chapter 1. Now, the first one we're going to look at is horizontal translation and vertical translation. And when we talk about translation, that is a fixed movement up, down, left, or right. It's not changing how the graph looks. We're just literally grabbing it and moving it up, down, left, or right. Now, our horizontal translation inside the parentheses, when we add or subtract a value, we're moving it left or right. That's all we're doing, left or right. And the movement left or right is going to be whatever the value of h is. Now, this one is sometimes a little tricky. And again, the best way I can say it is it's the opposite of what we think it is. Because if h is less than 0, it moves to the left. If h is greater than 0, it moves to the right. And an example of this here, as I kind of said earlier, we could say x minus 4. So what is the value of h? H is just 4. Because again, the general form of this is x minus h. The x is the same, the minus is the same, so the value of h is just positive 4, which means it's moving to the right 4. But if we look at it, x minus 4, it doesn't look like the h value is positive 4. It looks like it's negative 4, yes? So that's why I say it's the opposite of what we think it is. It looks like it should be going left, but it's actually going right. The same is true with if I said x plus 4, and both of these should be squared technically. Again, this here, x plus 4, it looks like it should be going to the right 4. But the value of h in this case is not positive 4, it is negative 4. Because what this is really saying is that we have x minus negative 4 squared. We don't leave a minus and a negative normally. We make it a plus, yes? Now again, we could delve back into this and really look at kind of what this is, or, as I say, is when we look at this here, it's the opposite of what we think. Because if it looks positive, we have that plus, it's not moving to the right, it's moving to the left. And if we have the minus, it's not moving left, it's moving right. It's the opposite of what we think. Now, vertical, up, down, that's exactly what we think it is when it's outside that parentheses. If it's plus 4, it's moving up 4. If it's minus 4, we're moving down 4. Up and down is exactly what we think it is. Inside those parentheses, it's going to be the opposite. So let's look at this first example here. Well, before we do this, any questions on any of this so far? We feel good with this so far, yes? Now, when we look at this first one, we want to describe the function, this transformation of f of x equals x squared represented by this here. We want to see how are these transformations affecting the function. So we have g of x equals x plus 4 squared minus 1. We have two transformations. We have the plus 4 inside the parentheses and the minus 1. So the plus 4 inside the parentheses is moving it to the left or to the right. Which direction? It would be left, exactly. How far? 4. Because again, inside those parentheses is the opposite of what we think. Since it's plus, it's moving left. Now the other one is the minus 1. Now outside is moving it up or down. And it's exactly what we think it is. Since it's minus 1, it is down. How far? 1. Down 1. And that's the answer. Mm-hmm. Now it does say to graph the function. I don't put a lot of stock in having y'all learn exactly how to graph, because at this point there's so many different ways in technology that we have that'll graph for us. One of them is the TI-84 plus graphing calculators. I typed it in, y equals x squared. It graphs the function. And we can use it to really get to the graph, so there's not a whole lot of reason for us to graph it. Because here, x plus 4 squared minus 1. To get to our graphs, or plug the equation in, we can hit y equals and go down 1. Parentheses, x plus 4, close parentheses, squared, minus 1. And then I can hit graph. And it graphs it for us. We don't have to know how to specifically type it in. Or we know how to type it in, we just don't know how, we do not have to know how to actually graph it by hand. So that's part of the reason. The other big thing is I'm more concerned about you having an idea, a mental image of the graph and what it's doing. Because when we get to solving these here, we start solving these equations, if I know how it's going to affect the function or what it should look like, that's the biggest thing. That way I can know what type of solutions I should have. And if we look at the one in red compared to the one in blue, it did move to the left, yes? And down. And specifically, it moved left 4 and down 1. That's all I want. Questions on this here? Let's look at the next one. Describe the transformation for this here. We have x minus 3 inside the parentheses. So it's moving to the right. How far? Right 3. Because inside the parentheses, when we have that addition or subtraction from x, it's moving left or right. Opposite of what we think, so it's right 3. That's it. Questions on this here? Let's look at the next one. We have two transformations. Okay. It would be right 2, because the x minus 2 inside the parentheses would indeed be right 2. And the minus 2 outside is exactly what it looks like, so it would be down 2. That's it. Questions on this here? Are you ready for the next one? So we have x plus 5 squared plus 1. It would indeed be left 5 and up 1. Is the x plus 5 inside the parentheses? Opposite what we think. It would move to the left, and then we'd move it up 1. Questions on this here? H of x equals x minus 1 plus 2. Yes. The x minus 1 inside the parentheses would tell us it's moving right 1. The plus 2 outside tells us it's up 2. And that's it. Questions on these translations to the left, right, up, or down? We feel pretty comfortable with this here so far. All right. Now we're going to apply, well, technically 3 more different types of transformations. The first one's a reflection. When we talk about reflections, we're talking about these negatives. A negative in front of the x squared, or negative in front of the x inside the parentheses. If it's outside parentheses or the parentheses are not included, it's a reflection across the x-axis. That means instead of going up, it's going to go down. Reflection across the x. If it's inside the parentheses, it's going to be a reflection across the y-axis. Now I will bring to note that it does say negative x squared inside the parentheses is the same as x squared. Well, yes, this is true. Because if we talked about this here and I said negative x squared, we're saying what? Negative x times negative x. Well, a negative times a negative is a positive, and x times x gives us x squared. Yes, this is true. And the reason this works is because we're reflecting it across the y-axis. So every point on the left of the graph is now on the right, and every point on the right is now on the left. It reflects onto itself. That's also why, kind of similarly, if you look at a mirror, it looks the exact same. It's just your left side of your face, now your right. It's just a mirror image, it's a flip on itself. Now, this cannot be said to be true if we're away from the x-axis. So negative x plus 1 squared is not the same as x plus 1 squared. We can't just drop the negative on these here because it's not along that x-axis. These do not line up. And negative x plus 1 squared. Because if I go on and graph this here, we see that this is the function. If I drop that negative x plus 1 squared, we get this here. But we do see that the blue one, or the red one, is a reflection across that y-axis. It is a reflection. The blue one is a reflection of it, but we cannot say that they are the same function. Does that make sense? If it had just been the x term, not the plus 1 minus 1 without the other, we can drop it. I'm not going to count it wrong if you still leave it as parentheses negative 4x, close parentheses squared. That is true. That is the correct function. It's just stating here that we don't necessarily need it if it's just a single term. But there's nothing wrong with leaving it. Okay? Now, the other one we have is horizontal stretch and shrink and vertical stretch and shrink. Vertical is the nicer one of the two. It's a vertical stretch or shrink if we have a number being multiplied by the x squared or outside parentheses. If that number is greater than 1, it is a stretch. If it's between 0 and 1, it's a shrink. Greater than 1, it's a stretch. Between 0 and 1, it's a shrink. And the vertical stretch or shrink, that number outside the parentheses in front of the x squared, we're not talking about the sign being negative. We're talking about the number itself. It can be negative, but that negative is not talking about the stretch or shrink, horizontal or vertical. That's talking about our reflections. So vertical stretch or shrink makes sense. It's exactly what we think it is. If it's a number greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. Horizontal stretch when a is between 0 and 1. In the function, when the number is between 0 and 1, it's a stretch. It's a shrink when it's greater than 1. Again, this is talking about inside the parentheses. As we already said with our left and right movement, it's the opposite of what we think, yes? And again, a number between 0 and 1, 1/2, 1/4. These here, it looks like it should be a shrink. Opposite of what we think, it's actually a stretch. And when it looks like it should be a stretch, it's actually a shrink. Does this kind of make sense? And it'll make a little more sense when we look at these. Okay. Now, as I find with most of these here, looking at the definition is fine and good. I think we learn more when we actually look at a problem. Now, when we look at this here, we have the, apparently it's going to scroll, the negative 1/2 x squared. We don't have anything added inside the parentheses, so it's not moving left or right. We don't have anything added or subtracted from it, so it's not moving up or down. We have the negative 1/2 x squared. Well, the negative is going to be a, well, yes. The negative is purely talking about reflections. When we have negative in front of the x squared, or a negative in front of the x, we're talking about a reflection across. Yep. X-axis or y-axis? Is it inside the parentheses or outside the parentheses? Outside, so it would be x-axis. Inside is the y-axis. Outside parentheses is the x-axis. Inside the parentheses is the y-axis. If there are no parentheses given, it's understood to be out. It's understood to be outside. So the negative is a reflection across the x-axis. Now, as you were saying earlier, the 1/2 is vertical. Because again, we don't have parentheses, so it's understood to be outside the parentheses. So we're looking at the 1/2. The negative is purely talking about the reflection. So we're looking at 1/2. Is 1/2 greater than 1 or between 0 and 1? So it's going to be a vertical shrink of 1/2. Vertical shrink of 1/2. And when we talk about this vertical stretch and shrink, horizontal stretch and shrink, vertical, when we talk about vertical, we're talking up and down, vertical movement. And a vertical shrink means along the y-axis, it's going to be increasing slower than our original function. So here, clear these two out. So our original function was x squared, and this is our graph. So alpha y equals enter 1/2 x squared. So I'm not going to apply the reflection yet. If we just look at that there, we see that the red graph is wider. Yes, it's increasing slower along the y-axis. That's why we call it a vertical shrink. If it was a stretch of 2x squared, it's going to increase faster, which means it's going to be skinnier. And we can see that the black graph is indeed skinnier. It's increasing faster. That's why we call it a vertical stretch and shrink. Now, the other part was that it was a reflection across the x-axis, which means instead of going up, it's going to go down. Graph. We do indeed have that. So that's how the new graph would look. Questions on this here? Let's look at the next one. We do have two transformations, and I would highly encourage y'all to list the transformations with up, down, left, right first, then do our stretch, shrinks, reflections. I would do the up, down, left, and right first. So here, we don't have anything added or subtracted inside the parentheses, so it's not moving left or right. But we do have an up and down, yes? How far would it go? Up 1. Good, move up 1. Now the other transformation is the 2 in front of the x, yes? So horizontal stretch or shrink, yes? Now again, inside parentheses is the opposite of what we think, yes? What does it look like it should be? It looks like a stretch, yes? So it's not a stretch, it's a shrink of, you remember, so this is recalling back to chapter 1 when we did the horizontal stretch and shrink, applied it, yes? What did we have to do to apply it? We had to flip the value, yes? So when we look back at it, we've got to flip it again. Yes, and again, yeah. Right, so horizontal stretch and shrink, so vertical stretch and shrink is being multiplied by that x squared, multiplied in front of the parentheses. Horizontal stretch or shrink, it's inside the parentheses, in front of that x.
So it's
Right, inside the parentheses is opposite of what we think. We flip it to kind of make that adjustment of what it's doing. Now, vertical, as we just saw, with stretch and shrink, it's increasing faster or slower along the y, because that's what we talk, horizontal, or vertical, sorry, not horizontal. Now, horizontal, left and right, x-axis, yes? So 2x squared, if, again, we're saying it's a horizontal shrink, that means it should increase slower across the x-axis, yes? Because horizontally shrinking, it's not increasing as fast. Now, I'm going to clear this out. Parentheses, 2x, close parentheses, squared. I'm just going to do this here. I'm not going to do the plus 1. If we graph it, the red one, is it increasing slower than the blue left and right? Well, yes. It's narrower, yes? And that's what it's talking about with horizontal. Is we're not talking about it up and down. We're talking left and right. That it's increasing slower than the original, yes? And that's why we say a horizontal stretch and shrink. But that also means alpha y equals enter 1/2 x squared. Again, 1/2 horizontal stretch and shrink. It looks like it should be a shrink, but with horizontal, it's actually a stretch of 2, because we got to flip it. Now let's actually look at the graph. It increased faster along the x. But incidentally, it's increasing slower along the y. And again, this here, out of all of them, out of all the transformations we'll do, this here is one of the, you're good, trickier ones because of that flip. It's doing the opposite of what we think. But again, as we said with the left-right movement, it's the opposite of what we think. Horizontal still holds true. Inside those parentheses, it's the opposite of what we think it should be. Because 2, our brain, especially with vertical, is saying it should be a stretch, but it's actually a shrink. And when it looks like a shrink 1/2, it's actually a stretch. Now let's look at this one here. Do we have any parentheses? So that means horizontal stretch and shrink is not going to happen. Reflection across the y is not going to happen. Left and right, we don't have. But we do have a -3 out front. So we have the negative and the 3. Well, the negative tells me it's a reflection. Across the x-axis. Vertical, yes. Of 3. Because vertical stretch and shrink is exactly what we think it is. If the number is greater than 1, it's a stretch. If it's between 0 and 1, it is a shrink. negative 3x squared. So we do see that it is reflected across the x-axis, it's going down. And it is skinnier than our original function, so it is stretching along the y-axis. Questions on this here? Because the value of a is what? Greater than 1 or between 0 and 1? So it is a stretch. The negative is purely attached to reflection. Yeah, the negative is purely attached to reflection because by definition, vertical stretch is true if the absolute value of a is greater than 1. It's a shrink if the absolute value of a is between 0 and 1. This is the strictest version of the definition. So if we plug that a value in negative 3 in, the absolute value of negative 3 is 3. 3 is greater than 1. It is a stretch.
So the negative does nothing but just say reflection.
The negative does nothing but tell us it's a reflection, y or x. So especially if it's in front of x, there's not a number in front of it, because again, we want to put x first, x squared first. It's purely reflection. We don't attach it to the stretch or shrink. Now, if we look at this one here, we do have two transformations. What is one of them? Inside parentheses is opposite what we think. It looks like a shrink, but it's actually a stretch of 4. Horizontal stretch or shrink. Inside those parentheses, it's the opposite of what we think. And then our minus 2 is down 2. And for the longest time, I didn't include horizontal stretch and shrink in these lessons, but again, the key thing is just opposite of what we think. Once we get that down with inside those parentheses, it makes it a lot easier to look at. You're good. The opposite of what we think. Because again, if it's x minus 4, we're not moving left, we're moving right. And with that multiplication, we flip it. Well, let's look at this here. We have 1/3 x squared. Yes? Yes. Horizontal stretch of 3. Since it looks like a shrink inside the parentheses, it is a stretch. And we flip that 1/3 to become 3. Now, it's not always going to be 1/3, 1/4 that we've had. I mean, we could technically have 2/3 x squared, which means it's a horizontal stretch of 3/2. We just flip it. Let's look at this one here. We do have two transformations. What's one of them? Is there a negative in front of the x inside the parentheses? And we do have the minus 1, yes? What does the minus 1 inside tell us? Left, right, yes? It's going right. How far? Yes. Because we have the minus 1, x minus 1 inside, telling us left, right, the minus 1 from the x. Opposite of what we think, it is right 1. Right, we have, that is a spot where reflection occurs, but that 3 would have to be negative, yes? But there's another spot there, and it is if we look back, let's see here. So we do have reflections because that's where a reflection does occur, yes? Well, what else is in front? Vertical, stretch, or shrink. If it's out in front of those parentheses. Yep. So, and this would be vertical of 3. Because this is the same as our a times x minus h squared plus, okay, that a, if it's negative, out in front of the parentheses, if it's negative, it's a reflection across the x. If a is a number greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. Right, if the 3 out here was negative 3, then it would have been also a reflection across the x-axis. If the negative had not been here, but had been here, it's y. So if we had parentheses negative x minus 1, it would have been right 1 and then a reflection across the y-axis. So here, hopefully we're starting to get a little bit more familiar with this. Yeah. So again, there are 3 because we do have the negative, we have the plus 3, and we have the plus 2. So let's deal with the plus 2 first. Plus 2 on the outside is moving what direction? Up or down, and it's going to move up how far? Up 2. And again, I would always deal with up, down, left, right first. So up, down, we got the plus 2. The x plus 3. Plus 3 on the inside tells us moving to the left or to the, and that would be what? Left 3. Inside parentheses. Opposite of what we think. Multiplication. Because horizontal stretch or shrink, that value is going to be right there. Because the multiplication, 1/3 x inside the parentheses is the horizontal stretch or shrink. When I add it, x plus 3, that plus 3 is our left right. When we multiply the number in front, that's our horizontal stretch or shrink. Now, there's nothing else left inside the parentheses. The only other thing left is this negative out front, which is a reflection. Yes. Questions on this here? Questions on this here? And that is where we're going to stop for today. We're going to pick this up tomorrow.